Hello and welcome to this. In this video, we will dive deep into the intricate details of a lathe machine. We will explore the operation of its various parts. Before we dive in, let's first understand what a lathe machine actually is. A lathe machine is a versatile machine tool which is used to shape and size workpieces by removing metal. Its primary function is to remove the metal in the form of chips from a workpiece. This is achieved by securely mounting the workpiece on a machine spindle and rotating it at the desired speed. The cutting tool is then fed against the workpiece longitudinally or crosswise to shape it according to the specifications. Now let's understand the construction details and the operation of different parts that come together to form a lathe machine. First and foremost, we have the stands or the legs. The legs are usually made up of cast iron. They are made to bear the entire load of the lathe machine. They are high shock absorbance and wear resistance capacity help absorb vibrations during work and transfer them to the ground. Above the legs we have a tray, also known as a chip span. This is positioned below the bed and above the legs. Its main function is to collect and carry the hot chips generated during the machining process. Speaking of the bed, it is the foundation on which all the lathe parts are mounted. The bed is a massive and rigid single-piece casting. It is carefully chosen to support the active components of the lathe machine. Depending upon the specifications and requirements, the bed is typically made of semi-steel or chilled cast iron due to their high compressive strength, shock absorbent properties and excellent lubrication qualities. In the case of larger lathes, 2 or 3 pieces of bed may be casted and bolted together, while small general purpose lathes usually have a single piece cast bed. The bed features guideways that facilitate the movement of tailstock and carriage. These guideways ensure smooth and precise motion along the bed's length. Now moving on, we come to the feed box. This is connected to the lead screw and feed rod. The lead screw, an external threaded shaft or rod, converts the rotational motion into linear motion. This is primarily used for thread cutting operations in the lathe machine. The feed rod, on the other hand, is a cylindrical rod without external threads. It serves to move the carriage from left to right and vice versa. Now let's shift our attention to the headstock and tailstock. The headstock is located at the left end of the lathe bed. It houses the driving mechanism, which includes the electrical mechanism of the lathe machine. It transmits power from the spindle to the feed rod, lead screw and the thread cutting mechanism. The headstock features speed selectors for controlling gear speed, and a driving clutch lever engages or disengages the spindle from the gear mechanism. This driving clutch allows us to control the motion of the lathe, engaging or disengaging the spindle with the gears as needed. The spindle, which is connected to the headstock, plays a crucial role. It possesses a live center to which the workpiece can be attached. The spindle is hollow inside, which allows long bars of workpieces to be handled. The chuck, with internal threads, fits onto the external thread of the spindle, which forms an assembly. The chuck securely holds the workpiece during machining operations, and depending on the requirements, we use either a 3-jaw chuck or 4-jaw chuck. The 3-jaw chuck, also known as a universal chuck, is ideal for holding cylindrical jobs, while the 4-jaw chuck, also called as independent chuck, can hold square jobs in addition to the cylindrical ones. On the right side of the lathe bed, we have the tailstock. This is made up of cast iron. The tailstock moves along the bed's guideways and can be adjusted forward, backward, towards or away from the chuck. Its primary purpose is to support the long end of the job, reducing vibration and sagging during machining operations. The tailstock holds the tool for various operations like drilling, reaming, tapping, and can also create a small amount of taper for a long job by offsetting the tailstock. One end of the tailstock is also known as the dead center, which provides support without motion. The other end, also called as the live center, rotates with the job. Both the live and dead centers have a 60-degree conical point to fit the center holes in a circular job. To ensure stability, the tailstock assembly includes a ram clamp and a hand wheel. The hand wheel enables us to move the dead center back and forth, while the ram clamp locks the dead center in a place which prevents the movement. On the left side of the headstock, we find the main driving pulley and gear mechanism. This system, connected to the gearbox inside the headstock, enables the power transmission. The driving pulley, which is connected to the motor through a belt, ensures the spindle starts rotating. Now let's explore the carriage. This is also a vital component of the lathe machine. This provides a rigid support system for the tool, transferring power from the feed rod to the cutting tool through an apron mechanism. The carriage simplifies the thread cutting operations using the lead screw and half nut mechanism. The carriage is composed of 5 parts: the saddle, cross slide, compound rest, tool post and an apron. The saddle, usually made of V-shaped casting, mounts on the lathe bed and supports the cross slide. The cross slide is actuated by a screw which moves the saddle perpendicular to the bed. This allows for cross movement. Above the cross slide, the compound rest can be swiveled to any desired position in the horizontal plane. This supports the tool post and cutting tool, which facilitates turning angles and boring short tapers. Mounted on the compound rest, the tool post plays a crucial role in holding various cutting tools or tool holders. It fits into T-slot in the compound rest and holds the tool securely in place using the tool post screw. The apron, which covers the mechanism inside the carriage, transmits motion from the feed rod to the carriage. This contains gears, clutches and a half nut that engages with the lead screw for cutting threads. Acting as a housing for all these mechanisms, the apron ensures smooth motion. Now below the lathe bed, we find an oil sump. This serves as a reservoir for machine oil, collecting oil from various parts, especially the shaft. The oil sump keeps the lathe machine lubricated for optimal performance. Also, there is a space available on the leg of the lathe machine, which can be utilized for storing gears, chucks, tools and even as housing for the motor mechanism in some lathe machines. And there you have it. We have covered the construction details and provided a detailed overview of the operation of different parts of a lathe machine. If you found this video helpful, please consider subscribing to our channel for more informative videos. Do let me know in the comments if you have any doubts or suggestions for future videos. Thank you for watching. See you again. Goodbye.